plan. Again, reminders, next class is retest. If you aren't going to be here, I think at this point everyone should have told me, but they will be in class. If you are not retesting, have something to work on that will keep you quiet and out of the way, something to work on or something to watch. And then when all the retests are done, then we can move around, socialize, play games, whatever. But we have to just give time for that. If you're taking more than 4 retests, you might want to try to find a time to come in and get started on those, because I don't know if you can get 4 done or more in that amount of class time. Does that make sense to everyone? Are we studying for those retests if you are taking them? I hope so. Don't just think you're going to show up and it will be like, yay, I did it. But anyways, this is the last lesson of the calendar year. And it's over inverses again, so it's going to be a lot of the same idea. It's just that we're studying we're taking inverses of different functions. These functions are even. Remember I said evens this time are the annoying functions because they have more things we have to be careful about. There is a little bit of homework. I believe that we should get done in time for you to work on the homework, but we talked about what it means to be an inverse, what it means to be one-to-one, all of that last time. So we are now, there's not a page here, but it says 7.3 inverses of quadratic. We're also going to include square root function here. I got to kind of tell you the difference and why this is a whole separate day over the next page and a half, and then really all the algebra is going to ultimately be the same, but there are one type of problem that you have a little bit of extra work to do. So when we start with the quadratic parent function, if you are retesting Unit 4, Topic 1, you need to make sure you know this graph and these points, these transformation points, because there is quadratic transformations on Unit 4. So we're looking at this function right here, our parabola with the critical points -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So last time we talked about what it means to be a one-to-one function. Is this a one-to-one function? Yes or no? What does it mean to be a one-to-one function? Yes.
It's like the horizontal line test.
The horizontal line test, that's how we tell from the graph. So is this going to pass the horizontal line test? So is it one-to-one? No, it is not. It is not one-to-one. From the graph, again, we can see that it fails the horizontal line test. But really what that horizontal line test tells us, to be a function, x cannot repeat. To be a one-to-one function, y cannot repeat. So when you look at the table right here, what do you notice about these y values? They're repeating. Okay, so that's how we can tell why it is not. From the coordinates, we have repeating y values. It is still a function because the x values do not repeat. But the problem that makes it not one-to-one is because the y values will repeat. And what happens when we find an inverse, remember an inverse is you just switch your x's and your y's. So if I take each point here and I switch them over, I now have something that is not a function. Y is what I'm writing over here in green, not a function. What do I have now? Repeating what? I have repeating x's, which make it not a function. If you were to put these on the graph, go ahead and do this. So we have 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. So if you were to graph this whole thing, you would see kind of this sideways parabola looking. And if you look at that graph, it's not going to pass what test? The vertical line test. Okay? This isn't going to pass the vertical line test. So that's why this is not a function. Okay? No function. Not a function right here. Okay? Repeating x's fails the vertical line test. So when it comes to using the inverse notation, I am not allowed to use f inverse x here because it's not a function. I'm going to have to use y inverse. That's kind of the difference. That's nitpicky. But technically, when you are finding an inverse, it has to be a function if you're going to use that fancy notation. I think a lot of you guys don't really use that notation, but I just want you to understand like when you can and when you can't. So we kind of already answered number 3, but based on our answer above, will the inverse be a function? Well, we've already said no. Why can it not be a function? Because the original one is not what? 1-to-1. That's kind of our like reasoning as to if an inverse will be a function. So we would say no, and the reason why is because f of x is not 1-to-1. And all those reasons that we said, the x values repeat, the doesn't pass the vertical line test, all that works there. We still can't find the equation of the inverse, but again, the equation that we're finding is not a function. And then I'm going to talk about like, okay, we know this happens, how do we fix it? But what's going on here? So if our original was y equals x squared, this is kind of what's a little bit different from the next, these types of problems. We still want to start by switching our x value and our y value. Anytime we find an inverse, that's what we're doing algebraically. We undid a power of 3 by taking a cubed root. How are we going to undo a power of 2? You already know this. Square root. But this is something that's going to come into play next semester. And this is something that is, I don't really know if you've looked that intensely before, but I do not have a square root in this problem at all right now, do I? No square root there. So I'm going to manipulate the equation by taking the square root of both sides. Now, when you go in and you actually are like, I am adding a square root to this, you have to consider both the positive and the negatives of that square root. It is not just the principal. You have to consider both. Because what is 2 times 2? What is negative 2 times negative 2? So you got to consider both sides of it. And it happens when you do the actual, like, I am square rooting to undo something here. And so what this will give me is this will give me the positive and the negative of the square root graph. That'll give me the inverse. And I can't use f of x, f inverse x here. So that's why that graph, I'm going to move my paper back up a minute, and I'm going to put this in here. This is my inverse equation. I've kind of got two graphs, two parts of it. The positive square root and the negative square root. So this is the positive square root. We studied that last week. This is the positive square root graph, and then this is the reflection of that. So they kind of, it's kind of like a mix of two graphs. You got both to consider. Now, when we get into solving these next semester, like actually solving for x itself, we are going to have to remember there are going to be some cases when we have to consider both. But when we talk about inverses, when we talk about graphing, we always want functions. So here's kind of our workaround. So we all agree this causes a problem because the original's not 1-to-1. How do we fix it? Flip over and I'll show you. And then you'll see how these problems are set up. There's really not much different in the solving than it was last class. It's more about you have to kind of understand when it gives you this extra piece of information or when you have to write that extra piece of information. What?
Nothing. It's fine.
Do you have a question about what we're doing right now? Or is it old stuff?
I just missed something on number 4.
Okay. I'll flip that over. 4?
Yeah.
So again, this is going to be important, and I will come back to this mid-January. I'm going to be saying, I told you so, one time when no one wanted to do work, but we have to learn anyways. Okay, so here's how we fix it, okay? So we are going to put a domain restriction on our graph, which is not 1-to-1. There are going to be times, here's what can get tricky about this. There are times when the domain restriction is given to you, and really you look at it and you say, okay, this is what that means. None of my algebra changes. There are also times when you are responsible for writing in the domain restriction. So that's why I need to explain the difference between. But that's just the only time you have to worry about this is quadratics and square roots. Odds, cubes, roots. There's nothing weird about those. But because the quadratic function is not 1-to-1, which we talked about, all the things over there, the domain must be restricted so that way we can find its inverse, and that inverse will be a function. So here's what we do. If the domain is restricted to where x is greater than or equal to 0, then we can actually figure out that the function is just one of those branches. So if you look right here, here's my parabola. You see half of it is dashed and half of it is not. That's because they took this right here. Let me box that. They took f of x equals x squared, but they said, I only want to look when the x values are greater than or equal to 0. So just this solid part of the graph right there, just this little half parabola that I just kind of drew over, that is the only portion of the graph they're talking about. Now, if I look at just that portion of the graph, is that little branch, that half parabola, 1-to-1? Yes. So now I have a 1-to-1 function, only looking at these, ignoring the other side, and then I'm able to get an inverse that actually is a function. That's like, in theory, what we're doing. We're only looking at half the graph, so that way we can ensure that this guy will be a function. Everything else is the same. So my inverse would be 0, 0. I'm going to switch these x and y's. 4, 2, 9, 3. If you recognize these are the key points of this square root function that we transformed 2 classes ago. Okay? And that graph I will draw right here. 0, 0. Oh, I'm sorry. I didn't mean to put 1, 1. I didn't mean to write 1, 0. I meant to write 1, 1. 4, 2, 9, 6, 7, 8, 9. And so this will be the inverse here. So this is x squared, and this is square root x. So again, what affects you is you just have to understand when you see that domain restriction, what does that mean? We'll talk about it on this one. And then I'm going to show you when you have to actually write the domain restriction yourself. And it really is just these squares and square roots. Remember, evens are the annoying ones here. Okay? So example number 1. We have, what kind of function is this? No. It's the one that we spent like literally the past 6 weeks talking about. It's a quadratic, okay? But notice, I gave you this, okay? All that is telling you, what would be the vertex point of this quadratic?
0.
The vertex would be 0 what? 4. Very good. How'd you know?
+4.
+4. It's going up. There's no left-right change, so that is my vertex point here. And where did this 0 come from, do you think? Right here in the domain restriction? Where do you think it came from? The axis of symmetry, the x value of the vertex. So basically, it says sketch a graph. I'm not going to sketch that pretty of a graph, but I am going to plot the vertex, which is about 0, 4. We'll say, okay, that's here. This graph is concave up because what's the a value? Positive, but I only want its right branch. So I'm looking at this little piece of the puzzle right there. That's what that domain restriction tells me. I'm only looking at this. Is this guy 1-to-1? Yep. Go about your business as we did last time. So I switch my x and y. So I'm going to have x equals 1/2 y squared plus 4. The only thing that is different is I need to know I'm looking at a half parabola. My inverse will be a function. Nothing's changing. What do I move first in this situation? By subtracting. So I have x minus 4, so that's going to take that out. What do I need to move next? The half by multiplying by 2. What did I wrap around in parentheses? My x minus 4, so make sure you do that. You have to get the function itself isolated. I've got to get the y squared alone. Okay? How do I undo a square? Take a square root. But I already have a restriction, so I do not need to consider both of them. I only consider the positive one because of this wording, so it really don't have to do anything about the sign. Just square root both of those, and that will get me my inverse function, which I can use this notation due to my restriction, square root of 2 times x minus 4. And what kind of function is that? Square root. So kind of back to, I think I talked about this last time. I like to have an idea. If I start with the squared, I better be ending up with the square root. If I start with the square root, I'm going to end up with a squared. Okay? And a square root graph, could you all kind of tell me where that's going to be? Where's the starting point for a square root graph? Still the C and D value. Flip.
0 +2, 4.
This one is in with x, so it's your x value. So 4, 0. So it would be 4, 0, and it would be going up because there's not a reflection out there. So I kind of like to think of it, if I started with one branch, I better end with one branch. And I do think it is worth kind of sketching these graphs. And I think it will help you figure out when you do have to write a domain restriction, what it means. We're not going to confirm this inverse. We'll do another example later. That's the same thing, though, that we did last class. Okay? So you flip over and try example 2. Don't go to example 3. I want you to do one of these. We'll do example 3 together. You'll do a practice. We'll do compositions. There's a mistake on this domain. It should be x is greater than 3 over 2. Just go ahead and write that down, then we're going to talk about it. It's for when x is greater than or equal to 3 over 2. So again, I kind of told y'all that the vertex point of your parabola has to do with your domain restriction. Why is it 3 over 2? Anybody know? Because what?
Because it has to move 3 and it's like divided by 2.
So when we get in transformational form, vertex form, we have to have that b value factored out. Now, I'm not going to make you do that. You can leave it in there. But because there is that 2 right there, if I were to factor it out, that 3 would then be divided by 2 and made positive. Okay? So that's how I knew that should have said 3 over 2. So my vertex is there. It's concave up. That's what I'm looking at there. Okay, kind of tricky, but this is more just for you to kind of understand like what's going on. You've got a 1 branch, it's 1-to-1, its inverse is going to be a function, and we're good there. And then you can go about switching x and y. Yeah.
So for this one, is it like 4?
Is what?
The one before? With the domain?
No, because the x value of it's whatever the x value of the vertex of the parabola, that's where the restriction should be. Because that's where, like, you're going to get half your graph. It's either going to be, like, the left-hand side or the right-hand side. Also, people sometimes ask, could you do a less than? Yeah, you could. Are we going to? No, we're not going to. But you could do that technically. You would just have a reflected graph, ultimately, is what that looks like there. So, switch your x and y and then keep solving. Problem, after you switch x and y, do you need to move anything, like, right now? No, I've got the quadratic part by itself. So the first thing I need to do is get rid of the squared by square root. Because of the restriction, I don't have to worry about anything there. So I have square root of x is equal to 2y minus 3. Now what do I do?
Plus 3.
Add the 3. Does that go inside or outside the root? Very good. And then multiply by 1/2. If you do that, what do you have to put around? Because there's 2 terms here. How else could you do it? Divide everything by 2. I prefer to stay consistent, which is what I have here, but technically you could also divide it by 2. And you do not have to write a domain restriction. So here's what I need you to kind of realize. When I give you a problem with a domain restriction, the only time that should happen, are you listening to what I'm saying? The only time that you should be given a domain restriction is when you have what type of function? Quadratic. And then you just recognize we're talking about a half parabola. Do your thing. Am I giving you a quadratic on example 3? No. Okay? So we're going to have to do something different here. What is your question before we start this?
Do I have to put f minus 1 of x, or can I put y minus 1?
You can put y inverse. It's a little more formal to do this, but because of the domain restriction, you can do this as well. Okay? Okay, so if you see homework problems and you see a domain on there, it's not going to freak us out. We're just making it 1-to-1. We all in agreement on that. All right, here's what you're going to see next. What type of function is example 3? This is a square root. Square root. What would the starting point of this square root graph be? It's like the vertex. It's not an actual vertex point, but it's kind of in the same spot as a vertex here. So what would the starting point be? -5, -6. Okay, so that would be my starting point. So if I were to graph this, I would go to -5, -6. Again, I'm just very much eyeballing this, but I know at least what quadrant to start in. And there's no negatives or reflections anywhere, so this is going to look something like this, going this way. And how many branches are in this graph? 1, okay? No domain restriction on here to start with. So let's actually find the inverse, same thing we have been doing. X equals 4 times the square root of y plus 5 minus 6. We have to isolate that radical, isolate the square root. So what has to move? Plus 6. Then what? All over 4, or how do I prefer you write it? Times 1/4 equals the square root of y plus 5. Got that by itself. Undo a square root by doing what? Okay. Be careful with your parentheses here. You're going to have double parentheses because the 1/4 also has to be squared. That matters, you guys. Have to write it that way. So then I end up with this function, 1/4 times x plus 6, all of that squared equals y plus 5. And then what do I do with the plus 5? Subtract it over. But then we need to talk about what we're looking at. There is one more thing in these types of problems. So take note of this type of problem. When it starts as a square root, you have a little more work. Okay? Because how many branches did our original graph have? 1. What kind of graph do I have here? How many branches does a quadratic have? 2. You can't go from 1 to 2. Okay? So we have to go in and say for domain, this is a different part, domain, x is, now remember what I said, it's based off of the x value of the vertex. So this guy right here, greater than or equal to, what's the x value of the vertex? Not the, no, that's the y value. -6. And you have to add that little phrase with these types of problems. Because that makes it actually be a quadratic, -6, -5, one branch to one branch.
Graph that you did, like the first one, that didn't go over 0.
No, this one can because of, it couldn't go over negative, it couldn't be bigger than -5 because that would give me a negative in here. But it has been shifted, so you can take, because you could plug in a -2 for x. -2 plus 5 is still positive. The problem is when you start getting negatives in the radical. Okay, yes?
So in the inverse, is the vertex just going to flip the coordinates?
Yeah, the x value of either the vertex point or the starting point of any of them is always going to be the opposite of what's there. You just have to make sure that technically it's factored out, which is why I don't want y'all really multiplying that all the way in. And would rather you write it as the actual reciprocal and not just like over. But it's going to be the opposite of like whatever that is. And that should match on this type of problem when it's given to you. That's where that's coming from. When you have to write it, you got to know where it's coming from. Right there. So flip over real quick. Try number 4. Take note. What kind of function is number 4? It says square root. Okay? So then, do you need to write a domain restriction? Yes, we are saying yes. We will need I'm going to make a note. You should end up with a quad, which is 2 branches, so you need a restriction. If you're asking in the bathroom, wait till I'm done. Need domain restriction. We're doing this one. You do this one. Good questions. I know it is kind of weird. It's like, and it's really nitpicky, and that's one thing that you'll see about radicals, like, that are just annoying in general. Like, I honestly hate this unit because there are a lot of, like, picky things with that. But just kind of understand, the first thing is you got to know, if you have a domain restriction, what does that mean? Doesn't really change your work. You just have to understand. And then if you have a square root and you end up with a quadratic, you got to write that domain restriction in. So you will have 2 problems to do on your homework that you have to write the restriction in. So you'll see I put a little star on my answer key and I said, need domain restriction, because we needed it there. The last thing is we're going to still use this inverse property. This composition property to test and see if things are inverses. You've got some of those on your homework as well. And again, that's composing the two. So we'll do these and then it's homework time. Okay? So we got to check both compositions, f of g of x. And these can get kind of weird looking. I know. It just is kind of part of it, especially when they truly are inverses and like everything's just kind of like falling apart. It is a little bit weird. But so I'm plugging g, which is square root of x plus 1 over 3. This is my input of f. And I do like to actually write it like this because to me it gives me an idea like this is going right here. Okay? So I can kind of see big picture what I'm doing. So function f says 3, open up a parentheses, what is our new x going to be? The whole thing. Function g, square root of x plus 1 over 3. But function f says I square it and multiply by 3, then subtract 1. So like there's kind of a lot going on. And you're just going to clean it up, little piece at a time. What happens when you have a square root squared? They undo each other. And you're left with just the x plus 1 over 3 part that was underneath that radical minus 1. So now it looks like this. Radicals and exponents are gone. They unraveled. Now I have a multiplication, which I have to do first. But what happens with a big 3 and a 3 on bottom? Simplifies to 1. So then I'm left with x plus 1 minus 1. Oops, not minus x, minus 1. And then what happens with your 1s? They zero out. And so you now know that f of g of x equals x. That little piece. So what do we do now? Reverse it. It's kind of nice when you get a no with the first one, because what does that mean if you get a no? Just do the other one. But you should have an idea if you're getting a yes, the other one should work out, but mathematically you do have to show it. 3x squared minus 1. And if it helps, I can put my input in parentheses like that. I don't really have to, but just so you can kind of see where that came from. And with this, you're kind of cleaning up. It's like everything is going to cancel out in the reverse order. What happens with your 1s up here? Those go away. And then you have square root of 3x squared over 3. What happens with your 3s? Simplify out. And then you have square root of x squared, which is just x. So now you prove the other way. G of x. And so are they inverses? Why? Both of those compositions equal x. Because f of g of x equals x and g of f of x equals x. And then you could try 6. I think 6 is a no. Yeah, I think it's pretty fast actually. You can see that it's not going to work. So this says square root x plus 2 squared. So you would have to do this. Is that going to give you x? No. You can tell right there it's not going to. So no. Not inverses. Okay. So homework is about the same length as 7.2 was. When you get that done, you can come check it with my key. And I do want y'all to get that done. If you don't have it done, we can work on it next class if you're not retesting. But I do want you to get that completed and checked with my key, and then, yeah, you can use this time. Oh, yeah, I'm going to be talking to you about course schedules. That's what I'm doing next. Okay?